I'm here with Mike Graves, technical lead of the Rocket City Space Pioneers. Mike, what is your current role at Dynetics?
I manage the Space Vehicles Department, and what we do is we develop small spacecraft for DoD and NASA. Like FASAT here, this is a half-scale model of the FASAT spacecraft that we launched last November, and it carried 6 experiments into low Earth orbit. FASAT was kind of a unique project in that it was commercially developed. It was commercially funded by Dynetics, and we developed it in conjunction with NASA to meet responsive space needs to get experiments into outer space. For example, FASAT carries 6 different experiments, and some of these are from NASA Goddard Space Flight Center to do heliophysics experiments, and they were developed and put into orbit in less than 2 years. And one of the reasons why FASAT is important to the Space Pioneers is that we're taking some of the technology that we developed in the avionics and the flight software and some of the structural techniques and applying that to our lunar lander for Rocket City Space Pioneers.
Can you tell us about some of the other projects you've worked on here at Dynetics?
Yeah, well, I've been at Dynetics for almost 19 years now, and I've got the chance to work on a lot of challenging projects over the years. Back in 1993, I was working on an unmanned ground vehicle project that did some robotics and some sensors integrated onto a Humvee. And then right after that, we got involved in some work with the automotive industry, developing hardware and software products. We developed electrical test systems that did diagnostics on the vehicles and the assembly plants as they're being built. Anything with an onboard computer, our systems were used to program the cars and test them as they were being built. And so we developed a team within Dynetics to do commercial and be product-oriented within a company that was primarily services-oriented.
Right. What does a technical lead for a Google Lunar X PRIZE team do?
Well, as you can imagine, developing a system to put a lunar lander on the moon and row 500 meters is very complex. And we have really a broad team of engineering disciplines, from rocket propulsion engineers to guidance, navigation, and control, software, communications. It's a really diverse team. And what I do as a technical lead is to give them good direction on to come up with a solution that will get us to the moon successfully and reliably. As a system, we have to take each of those technologies together to come up with an integrated solution. So working with all those teammates and also a lot of times we have to make tough decisions on the trade-offs between one design and another, and that usually comes up to my level for decision making.
Could you give us an update on the technical milestones over the last few months?
Yes, one of the biggest things we've been working on for the past several months is developing a new rocket engine for the lunar lander. We needed better performance than a monopropellant system can offer, so we developed a peroxide kerosene thruster that's capable of doing 100 pounds thrust each. It looks like this is a ground test unit that we just recently tested, did a hot fire test out of our test facilities here in Huntsville. And basically what we have is a monopropellant peroxide thruster that was modified to inject kerosene in here through transverse injectors to give it better thrust performance.
Mike, what is the biggest challenge for the Rocket City Space Pioneers?
Probably the biggest challenge is to come up with a way to test the lunar lander on Earth. You've got to come up with a way to simulate the moon's gravity, and one of the ways we do that with NASA today is we put an Earth gravity canceling engine on the structure that provides about 5/6 of the Earth's gravity, but that affects the design of the lander, so you're not really testing the actual flight configuration, and you also can't necessarily use the same propellants that you would use on your flight unit. So the difficulty is gaining confidence that your design of the lunar lander and the algorithms to land it safely on the moon when you're doing it unmanned is going to work when it happens. Remember with the Surveyor missions in the Apollo era, there were 2 of them crash landed even though they went through a whole test program. So that's probably the biggest challenge for us, is to find a way to gain confidence in the design.
Mike, what are some big discriminators with the Rocket City Space Pioneers compared to other teams?
Well, we really have a very mature system design. Compared to some of the other teams that have focused on either the rover or the launch vehicle or developing a new launch vehicle, some of the teams are doing that. And one of the very unique things about our mission is our launch. For our launch, we're actually carrying not only our own lunar lander, but also additional spacecraft on the same launch to help fund the mission. So this is a launch ring adapter that the lunar lander is attached to, and we'll also carry some additional spacecraft up to low lunar orbit on this ring and deploy them separately. And when the lunar lander gets deployed, of course, we're going to descend to the moon and land safely, and our rover is going to travel 500 meters after that.
Right.
But the other spacecraft can be doing completely different missions, either science missions or lunar orbiters to gather data about the moon.
Right, very cool. Mike, you recently got back from the annual Google Lunar X PRIZE Summit. How do you feel the competition is?
Well, there were 28 teams that attended the summit internationally. There's teams from Russia, Romania, South America, and of course the United States. And really, each team had a chance to present their status to the other teams and talk about some of the common challenges we had. From my perspective, it seemed like there's about 3 or 4 teams that really have a mature system design, are really well on their way to competing for the grand prize for the competition. And the other teams are maybe a little bit later. They just joined the competition and aren't as far along. One common theme I think that many of the teams have is that we all have a good education outreach program. And it was very inspirational to see the number of children. There's got to be thousands, if not hundreds of thousands of children that have already been touched by this program. So even for the teams that don't go all the way, they've inspired some young engineers.
Mike, I understand that other spacecraft can share your launch. Can you tell me more about that?
Yes, that's right. We have excess launch capacity. We're going to purchase a Falcon 9 launch vehicle, which is, by the time we launch in 2014 or early 2015, is going to be a very reliable platform. They've already had some successful launches. But one of the ways that we carry additional spacecraft is on this Esper ring that they can attach to. And this is a proven launch architecture. The Esper ring has already flown with up to 5 spacecraft mounted to it. And it's tremendous benefit because each of the spacecraft don't have to purchase their own launch vehicle. So the cost is a lot lower for a spacecraft than buying their own launch vehicle and flying a dedicated launch.
Good idea.